Hello, we're Camber, and we're here to democratize scientific computing. 75 years ago, computing was started by scientists. Now, we're in the era of high-performance computing, and scientific computing is everywhere. From fluid dynamic simulations, from model development, big data and genomics, physics simulations for oil and natural gas exploration, drug discovery, and just for understanding the universe. This is a $40 billion a year market. And this may surprise you, but 90% of that market is still on premise. That means that science is 15 years behind the tech sector in infrastructure and tooling. Well, let me tell you about my friend Alice and how this affects her life. Alice is a young researcher, and her first task is to calculate the structure of a star on her campus's HPC cluster. Okay, great. So she's been given access to bare metal hardware. Now she has to figure out how to use it. Her main task involves using a massive differential equation solver that's often 100,000 lines in Fortran. Now she has to debug it for dependencies. She finally got it working, but she's not the only one. There are typically 20 people ahead of her in line every time she submits a job. The only way for her to monitor her jobs is through a clunky, old Unix shell. She finally gets her task done about a year later, but now she's starting to wonder why she got into science in the first place. This is broken. Okay, how are we going to fix this? First, let's be reasonable and build something in the cloud. Next, let's offer her managed distributed computing frameworks for her to run her calculations on. Those massive differential equation solvers that she was having problems with, why don't we pre-install and optimize them on our engines for her? Then we're going to wrap everything up in containers so she can deploy her jobs on demand in seconds. Finally, let's serve it up in an easy-to-use environment in languages she's comfortable with. This is Camber, the first cloud platform for scientific research. We provide tooling and a low-code API for scientific workloads, completely abstracting away infrastructure. So what does this do for Alice? Bare metal, now she can work in a notebook in an environment that she's used to. Those packages and libraries of 100,000 lines of Fortran, let's turn that into one line of code. In the cloud, there are no queues for CPUs. From sign up to completion, Alice gets the job done in 1 minute with a single line of code. Effectively, we've containerized science for scientists in the cloud. We're already working with 20 different institutions in astronomy, chemistry, and our first industry customer in genomics. And they love us. We're growing fast with $150,000 in ARR. We've cracked the go-to market for science. The academic market is our beachhead, and then we're going to move into industry in the field of genomics. Now is the time. There is an explosion of data in the scientific world. And only now are scientists beginning to scratch the surface of this GPU revolution. Wait, why didn't Alice just use the cloud to begin with? Well, the cloud is complicated and complex. It's very specialized. And normal DevOps won't work. You need a team that understands science in the cloud to build a solution that works for Alice. We know science, we know the cloud, we've made it simple. Believe it or not, my name is Aristotle Socrates. Now all your heads pop up. I'm a former theoretical astrophysicist. I've discovered more mechanisms for generating turbulence than anyone else in the world. My co-founder, Chen, came to the States when he was 14 years old without his parents. By the age of 20, architected his first platform in AWS. We're here to democratize science. Join us.